So we need to determine whether the given series is convergent or divergent. If the series is convergent, we need to find its sum. Let's try to rewrite this series. It equals the sum from n equals 0 to infinity of 3 to the power of n over 4 to the power of n plus 2 to the power of n plus 1 over 4 to the power of n. This equals the sum from n equals 0 to infinity of 3 to the power of n over 4 to the power of n plus the sum from n equals 0 to infinity of 2 to the power of n plus 1 over 4 to the power of n. This equals the sum from n equals 0 to infinity of 3 over 4, the whole thing is to the power of n, plus the sum of n from n equals 0 to infinity of 2 times 1 over 2 to the power of n. Well, we get two geometric series. In the first series, our common ratio R1 equals 3 over 4. And in the second series, common ratio R2 equals 1 over 2. If you look at it, the absolute value of the first common ratio is less than 1. And the absolute value of the second common ratio is also less than 1. That means that both individual geometric series converge. So this series converges, and this series also converges. Well, the given series is the sum of two converging series. So we can rewrite that the given series is sum of two converging series. That means that the given series is also convergent. So the given series is also convergent. Well, now let's try to find the sum of this series. We know that the sum of an infinite geometric series is given by S equals A over 1 minus R, where A is the first term. So then our first geometric series, the sum from n equals 0 to infinity of 3 over 4 to the power of n equals 1 over 1 minus 3 over 4. So it equals 4. And the sum of the second geometric series, so the sum from n equals 0 to infinity of 2 times 1 over 2 to the power of n equals 2 over 1 over 2, so it also equals 4. So that means that the sum of the given series will be the sum of those two series. So will be the sum of the sums of those two geometric series. So the sum of the given series from n equals 0 to infinity of 3 to the power of n plus 2 to the power of n plus 1 over 4 to the power of n equals 4 plus 4. So it equals 8. So our final answer is that our given series is convergent and it converges to 8.